Apologies for that interruption. I swear I did not do that on purpose, but my computer decided to reboot and it took a long time. It ended up reflashing the BIOS and then doing some other things. Okay, so we've been talking about benefits, in particular, the ability to have a known state in order to snapshot a VM. You essentially are taking the memory of the VM and writing it out to disk, and then you can bring that back in, overwrite the memory of the VM, or restore it to a known state. And that is much quicker than going through the actual process of booting up in order to get back to that state or something similar. One of the things, let me think, John, I've lost all the text since I just got back in, but I think John was saying a benefit is to emulate different CPUs. We can do that with emulation, but if you look here at the slide about the hypervisor, in the virtualization software applications we have today, in order to get the speed that is necessary for them to be useful, we emulate, we don't emulate, we give the virtual machine access to the real CPU of the real machine, which means you can only virtualize the same CPU. If we use emulation, you can emulate anything you want, but emulation is much, much, much slower, often cases unacceptably slower. Good perhaps for experimentation and research, but in terms of practical performance, emulation is not used. So virtualization is very commonly used today, but you can only virtualize to the same CPU. And you should have got an announcement from me. If you joined this, if you registered late, please make sure you check the announcements on the home page. One of the issues we have with this course is that the machines that we're going to be creating or using are all based on the x86-64 CPU architecture, the kind of CPUs you get from Intel and AMD. Apple, a few years back, stopped using those CPUs and used ARM-based CPU. It's sometimes called Apple Silicon for short. It's a different kind of CPU, and you can run the same software on a Mac, one of these modern Macs, M1 or later, and you can virtualize machines, but only the ones using the same CPU as the Mac. So essentially on a Mac, you can virtualize Macs. On an x86-64 machine, you can virtualize x86-64 CPUs, and the latter is what we're doing in this course. So if you have a modern Mac with an ARM-based CPU, you will not be able to use that for the work for this course. You're going to need to get access to some other machine or go to the labs, and I believe that Fairfax labs are the only ones that are open, although there's a lab at the SciTech campus, Johnson Hall 250 is a lab. I don't know if that lab has VMware software on it. That's managed by the university, not by our department, so I don't have any visibility into that. That lab, I believe, is open till 8 o'clock on weekdays. Don't know about Fridays. It's just a lab. It's not used for classes, so that may be suitable. Otherwise, there are labs at the Fairfax campus in the engineering building that have the software on it. Some or all of those labs are used for classes, so they're open to students in general outside of scheduled class times. I don't know about evenings and weekends and so on. You'd have to check the website for that. Okay, let's go here and let's talk a bit about costs. Costs or negative disadvantages. What are some disadvantages or costs of virtualization compared to using a bunch of separate real computers? Cost of memory allocation. Don't know what you mean by that. Memory allocation is fairly straightforward to do and is a fairly part of the execution. Daniel says speed. Yes, okay. So the speed is not going to be it's not going to be 100% of the performance of the real computer, because the real computer is running the operating system and the virtualized application in order to give the virtual machine access to the CPU. So there is some overhead that is not where the machine has access to the CPU. The CPU is being used for other things. But in many cases, that speed difference is not significant. So if you could get, let's say, 80% of the speed of a CPU, almost always that's going to be plenty for the kinds of things you need to be doing. If you need really high performance, we need the absolute maximum, then you probably need the biggest, fastest real machine that you can get, and make sure you're running nothing else on it except what you're trying to get done. Gilbert says cheaper than deploying multiple machines. I'm looking for disadvantages here. Stephen says resource exhaustion. Okay, so one of the, I think what Stephen's talking about is we've got limited resources on the real machine. This memory that I tend to draw on the top part of the diagram, that is finite. And this is true whether you're running virtualization or not. If your applications, let's draw a few applications in here, don't really care what they are, they need certain amounts of memory. And then if I've got one, I'm going to draw one over here outside the box like this. So this application I've got hanging off the side, it needs more memory than is available. Let's just assume all the other memories are allocated. So when you get to the point where there's not enough memory for the applications that want it, you then start swapping memory to disk and vice versa. We call this paging. So you take a chunk of memory called a page of memory, write it out to disk, and when you need it, you bring it back in. And the software is quite cleverly written to anticipate when things might be needed. But if it's needed and it's not in memory, you have to wait for it to be written in from disk. That takes time, and that can cause your system to run really, really slowly. If you are running virtual machines, they want access to all their memory. So let's redraw this. So you've got a finite amount of memory, and if I give this much of it to virtual machine 1 and this much of it to virtual machine 2, now there's not enough left for virtual machine 3 if it's the same width, if it was wanted to be this big. And you don't want to be paging virtual machines RAM. The RAM in the virtual machine is RAM in the real machine. It's just addressing is mapped perhaps to a different place. But you certainly don't want to get to the point where paging is going to become an issue, because then the virtual machines will be seriously impacted. So you want to make sure that the RAM in your virtual machines is much less than the total RAM in the system, because within the system, we have to run the operating system, the virtualization application, and then give memory to each of the virtual machines. So you want to make sure that you are not getting anywhere close to that 100%. Stephen, was that what you were talking about, resource exhaustion? Okay. When we're running multiple virtual machines, if we've got, let's say we've got 2 virtual machines, they are getting on average less than 50% of the cycles of the CPU. The CPU has to run the operating system and the virtualization application. So let's assume, let's say that takes, I don't know, 10%. That leaves the other 90% to be split between the 2 VMs. And if you split it equally, they get about 45% each. Now, again, that may be plenty. Our CPUs run at extremely high speed, and if your application is not CPU bound, if the speed of the CPU is not what's critical for your applications, then that may be absolutely acceptable. Gulam says memory allocation is required to run efficiently. Well, that is true whether it's VMs or not. Hugo brings up a very important point. I'm going to write here SPOF, single point of failure. If you are running multiple virtual machines in one real computer, and the real computer fails for whatever reason. If it has a fault, if it reboots like mine just did, if the operating system decides it's time to reboot and you don't get a chance to say no, then all your virtual machines fail. And when they fail, if you haven't captured the state is lost. So if you have a snapshot of a known state and then the machine goes on and it changes its state, it's updated, and then it fails and that memory is just lost, you have no ability to recover from that. So one of the vulnerabilities, if you're running multiple virtual machines, is a real computer failure affects multiple computers. Whereas if you had separate computers and one of them failed, you're only affecting one of them, not all of them. That, I think, is the biggest potential disadvantage of virtual machines. We have to understand that risk. In terms of benefits, I think cost may or may not be significant. I suspect it is not terribly significant. It may not be the cost of the actual machines. Space is an advantage. So rather than having lots of machines taking up physical space, that may be an issue in some environments. And space comes with other things, like you've got the heat generator, you've got the room that you have to allocate in order for people to work with things. But I think those things are probably fairly small, probably not the deciding factor. I think some of the other things we've talked about, the ability to bring things up quickly, to recover very quickly, I think is very important if you're running an environment where downtime needs to be minimized. If you're running an online store, for example, you don't want to be offline where people go and get, the web page is dead, there's no response, or you're not able to allow them to see products and place orders. That's critical. So I think some of those other considerations are perhaps more important. Okay, this slide about hosted. There's different ways for virtualization to be implemented. One way is for a company to provide services, and I'm going to draw this in the cloud. So here's the cloud, and within the cloud, we've got some company, and they can allocate one or more virtual machine instances to you, and you can access it through a network connection, which I'll make red just to make it a little easier to see. So that computer can be accessed by your system, and I'll draw another little cloud here. This is your little corporate cloud. So you can have a computer that's part of your corporate environment and it's actually supported by some other company. This may not be your company's core capability. If you don't want to have 24-hour computer operators and a server room and everything that goes with that, you can purchase this service from some other organization. And this is what companies like AWS and others are doing. They are providing virtual machine instances. How they do that, don't have a lot of details, that's proprietary, but I imagine they've got some really big, powerful computers that support many instances of virtual machines on them. And in this case, I've got one instance. There may be many, many similar ones that are the same or perhaps different OSs or different size in terms of resources allocated to them. Don't really know, don't really care. There is a risk that if that large computer fails, then all of the virtual hosted instances, of course, fail with it. But presumably the companies doing that have people who know what they're doing. This is part of their business, and they probably have the ability to do that better than small or medium companies trying to do this on their own.